Hey guys, welcome back. So today we'll talk about different ways to cool your CPUs. So in today's video we'll be discussing different mechanisms that are available to us to cool our CPUs. So let's get started. So today, if you talk about cooling your CPUs, there are various ways you can do it, but the two major ways, that at least are widely available are your air coolers and your, liquid coolers, you can say. Now, this is an AIO. We've been discussing a lot about them. So they are like, all-in-one liquid coolers, or they're also known as, closed loop or closed circuit liquid coolers. But you can also see, people use different kind of, custom cooling. But if we talk about the ways of cooling available to the general audience as a whole, like these are the two ways that generally CPUs are cooled. So if you talk about, the first one is your air cooler and the second one is your liquid coolers. Now we'll talk about that how actually they cool your CPUs. Like this is, we'll try to understand that how they actually achieve it, and out of these two, which is better for your CPU, or under which circumstances you should use either this or this. So let's get started with the, let's first discuss about your air coolers. So yeah, let's keep it there. So we talk about your air coolers. Now this is pretty much, the staple air cooler that you'll find in most of the cases. So this is, this is the stock cooler that comes with most of the Intel CPUs. Actually, all of them which don't have, a K after them. So like those CPUs which are, logged and are at, run at a stock frequency. So for them, Intel do provide these coolers. So they are pretty much in, you'll find them pretty much in all the Intel systems that are, not are not meant for overclocking. So if you guys open your machine, then you'll most probably find this thing in there, working with your CPU. So this is something that Intel provides. So this is, the pretty basic air coolers. There are a lot of different kind of air coolers available, but topic for today is that we try to understand that how this thing cools your CPU. So when we talk about cooling, we can talk about the first law of thermodynamics. It's like it's an energy and can flow from high concentration to low concentration. In general, we can say. So here we can, this is a very good example of heat transfer. If you have, we have studied in our schools or colleges. So this is a typical example of heat transfer. So what happens here is, this is the part, if you can see now, it's not very clean out here, but this is made up of copper, and copper is a very good conductor of heat. So because again, if you get into the science behind this, then we all know that metals are good conductor of heat, and the reason is they have a lot of free electrons. So that is the main reason that copper conducts heat very well. So that's how the heat transfer happens. So what happens is that this particular copper thing is in contact with your CPU, and a CPU generally have a top covering over them that's generally called as IHS, or their shield, you can say. So this particular copper is responsible for for the heat transfer, or pulling the heat. Now also, if you guys see, we have this kind of thermal paste applied on them before putting them on your CPU. And the main purpose of the thermal paste is again this, that it's responsible for providing a contact with your CPU, and that's the main idea, right? That the thermal paste provides a contact with the without any space in them. So that's the main idea, that this copper plate over here is responsible for conducting heat, and then it pulls the heat, and then it transfers it into this these aluminium fins that we have. Now the main magic that happens is in these aluminium fins that you can see that they are very like, there's a lot of grooves cut out into them. So the main what you can say, the logic that goes behind them is that they are responsible for pulling the heat from a CPU. This copper plate is responsible for pulling the heat. So that's why this sits on your CPU, and generally you lock with these new locks, because the main thing is that this copper plate should be in contact with your CPU. That's what the first thing. And the paste is responsible for for that last point of contact, to fill out any space or something, to provide an efficient heat transfer. So the first thing, when you talk about them, the heat transfer starts from this copper plate. It pulls out heat from your CPU, the heat that it produces, and this kind of these this aluminium whole block, we can say block of metal, is responsible for absorbing that heat. Or we can also say, if we talk about in the terms of thermodynamics, your CPU is a heat source, and these guys are your heat sinks. So they are basically taking in the heat from there. So that's what these guys do. they absorb the heat, and heat is spread throughout this metal because they are good conductor of heat. Now having these grooves play a very critical role. See, they are actually increasing the surface area. So in this particular amount of space, we have so much surface area because of these grooves. We can have a lot of air in between all these grooves, and that air absorbs the heat from these particular metal grooves. And the main function of these fans that you see is to just blow this air continuously, or they are basically doing is nothing but they are replacing the air between these grooves with the cold air, like, because the air between these grooves will heat up due to the heat that is getting transferred, and these fans will basically pull that air away and replace it with new fresh cold air. So that is the main fundamental science going behind cooling your CPU. So that's how your and normal air cooler is cooling your system. So if we talk about your like, there are variety of air coolers are available, so we generally put them together or compare them, that which one performs better. So the main magic that happens in an air cooler is based on how they have been able to create these grooves and other kind of stuff. So that's the main idea that goes in there. So yeah, that's the main thing, that all the architecture work goes into designing these grooves. The more efficiently you can design them, the better will the performance, the better your cooler will perform. So that's the main idea about air coolers. Now if you talk about your liquid coolers, like how these guys work. So again guys, if we check at the or look at the pump right here, like the pump that we have here. Now again you can see that this is all copper plate. Now right now that this AIO was not working, and I replaced this with a new one. So you can see that it's all blacked out. This is because of the hard CPU, but since this pump wasn't working, you can see that it started becoming black. So now this particular plate, we can say, is again made up of copper because it has a very good conductivity of your heat. So basically this plate is responsible for pulling out the heat from your CPU, and we apply this thermal compound again for the very same reason, that is to provide direct contact without any gaps with this copper plate with your CPU. So that's the main idea behind them. And after that this part and this part, like your air cooler and your AIO or liquid cooler, so when they are pulling out the heat from the CPU, it's pretty similar. Like, they are doing it in a similar manner. Again, they have a copper plate and that's pulling it. Again, here also we have a copper plate. But now once the heat is pulled out for an AI or air cooler, it basically pulls out all the heat and spreads out in the whole metal block that it has, and then dissipates through the air. But what happens in your liquid coolers are that once this heat is taken in, this particular pump is filled with an a liquid, generally a mixture of water and alcohol, that are good conductor of heat. So basically this heat from this copper plate is absorbed by the liquid filled here, and the main purpose of the pump over here is to keep on circulating it. So again as this fan out here was responsible for replacing the hot air from the grooves, the pump over here is responsible for pulling out all the hot liquid and just making it circulate. Now if we talk about an AIO, this pump is responsible for pushing out all the liquid throughout the radiator. Now the main fun part, or the main cooling happens in the radiator. So if you talk about these radiators as a whole, if you see these radiators and we have fans like these. Now when these high static pressure fans are attached to your radiator, they are basically pulling air and passing it to the radiator. Something similar, like they're doing something similar how this air cooler is working, right? Now what happens in the radiator, you can again see there's a lot of grooves in them, right? So that fluid flows through these grooves, and like a fluid flows through this groove and then again circulates back into your pump again, and this cycle keeps on going. Now then what happens due to these grooves, when the cold air is passing, the air is getting in contact with these grooves, and the hot liquid that's flowing in them, or the liquid that's carrying the heat from your pump to the radiator, it basically transfers those heat into these small plates, and these plates, or we can say grooves, basically get in contact with your air, and this air basically absorbs that heat, and these guys are responsible for maintaining a fresh supply of cool air, and that's how these guys are cooling. So what we can see that if we talk about surface area, this air cooler can provide only this much amount of surface area. You can see these grooves are there, but if you talk about these radiators, there's a way lots more surface area than what this air cooler can do. So that's why if we are putting or comparing your AIO or a liquid cooler with an air cooler, the main thing that you should look for is again what's the size of the radiator. Larger the radiator will be, theoretically should be cooling more, but it generally doesn't happen that way, because you know a lot of things are there. If your CPU is not getting hot, too much hot, right? So it's not getting producing a lot of heat, then maybe once the liquid reaches here, it's completely cooled down because of the air, and the remaining part of the radiator is not required, because even this much part is sufficient to cool your CPU. So maybe if your CPU is not producing a lot of heat and you are keep on increasing, you go on and start increasing the size of the radiators, it will have no impact, because yeah, even just a 120 radiator is sufficient for cooling your CPU. So that is something that you should look for, that when you're looking for a radiator or air cooler, is something that you should look based on the specifications of your CPU. If your CPU is something that really becomes hot, or you are planning to overclock, or do some heavy task on your CPUs that can make it hot, so you can decide on a liquid cooler maybe. But even some if you're going for an air cooler, then you should definitely look for the design, that how they are trying to create the surface area. So those things are really important. Even modern air coolers, if you see, there's also a concept of copper pipes are running through the metal plates, because copper pipes absorb heat quickly. So definitely there's a lot of things going on in these things, but this is the fundamental way how these guys cool your CPUs. So these guys are basically just the main thing that goes behind this is again surface area. The main concept that helps in cooling your systems is surface area. These guys are are providing surface areas like by making grooves in the metal, and these guys are providing surface area in the form of a radiator. But and like we can say the physics that goes behind them is pretty similar, and the way they are conducting your heat, that is something we can say is only different. Like here the air is getting in contact directly, while here this pump is responsible for pulling a fluid from there to here, and then the cooling things happen. So that's pretty much it, how these guys work. So I guess that was that definitely increased your knowledge, and helped you out to understand how the cooler which is inside your machine, how it's actually working. So that's how we can see that physics or science that we study in our colleges or school comes into action. So this is how these are very simple concepts of physics that are being applied to make these things. So it's it's really great to explore them, and if you look around yourself, you'll see almost everything is related to physics, and they are some or the other way based on those laws that we have studied. So yeah, that's pretty much how these things go. So with this, I put this video to close, and if you guys really like this video, don't forget to hit subscribe and like button, and if you didn't like it, definitely hit the dislike button, but do let me know what was the points that you didn't like, and I'll try to improve them, because learning is something that goes on throughout your life. So it's I really enjoy learning as we go. So till then, guy, take care and goodbye.